This is Bio 181, Chapter 3. Our key concept is functional groups. So functional groups are groups of atoms within a molecule that have definite chemical properties. So they have properties that are always going to be associated with those few atoms. So they may be nonpolar, have a completely equal distribution of charge. They might be polar, where there's a slight unevenness to the charge. They might have a full charge, extra electron, missing an electron. They might be acidic, where they donate hydrogen ions, or basic, where they gain hydrogen ions, or happen to be just very high energy. So if we can learn these 7 functional groups, then whenever we see them in a molecule, even without knowing anything else about that molecule, we'll know those specific characteristics are part of it. So I'm going to go through 7. And the first one that I'm going to go through is called a hydroxyl group. So it consists of an oxygen bonded to a hydrogen, covalently bonded. So remember that this, if I use a straight line, that represents a covalent bond, so electrons are being shared. I could also represent the rest of the molecule with the letter R. So that's just any other thing that's bound to the molecule. So it can be really big or really small. OH is called hydroxyl. So it has the name, hydroxyl. And you may remember that this actually occurs if you have the dissociation of water. So if water ionizes in a chemical reaction, you can have a dissociation where you have a hydrogen ion and hydroxyl group. We've seen that before. But in this case, the hydroxyl group is going to be bound to a molecule. So hydroxyl has the characteristic that it's polar. So the oxygen actually has a partial negative charge, and the hydrogen has a partial positive charge. If we were to look at the electrons, they're going to be spending a lot more time around the oxygen. It's more electronegative, and only a little bit of time around the hydrogen. So that gives it that partial charge. So this characteristic, anytime you see a hydroxyl group, you know that that part of the molecule is polar. All right, we'll go to the next functional group. So functional group number 2. And that's going to be carbonyl. So carbonyl, R is just going to be the rest of the molecule. The carbonyl group is a double bond O. So you have C, double bond oxygen, and then we have generally another molecule. So carbon forms 4 bonds, 1, 2, 3, 4. And that's just the nature of carbon. It's got 4 unpaired electrons in the outer orbital. So 2 of these are to another part of the molecule, and we're really just looking at this part here. So the characteristic associated with this is, again, that it's polar. It's polar. And oxygen, again, we're starting to see a pattern. It's electronegative, so this tends to be a little bit negative. All right, the next functional group, moving on, is carboxyl. Okay, so carboxyl, so the previous one, I didn't write down the name. Let me just write that down really quick. So we've got R, C, R. So this one was R, CARBONYL. It's carbonyl. The next one we're going to do, I'm just going to leave that up because these are very close. So the next one is called carboxyl. So carboxyl, XYL, so CARBOXYL, is going to be, we've got a molecule here, R, and then we've got a carbon, and then the carbon is double bonded to an oxygen, and then it has another bond. Remember, carbon has 4 bonds, So that fourth bond is to a hydroxyl group. So the functional group is COOH. So you can also write it as RCOOH. This is another way to designate that functional group. And this functional group has the characteristic that it's acidic. So that means it donates a hydrogen ion pretty readily, and this hydrogen ion will actually pop up the hydroxyl group. Remember, the oxygen tends to hog the electrons, they tend to be around it, and that leaves this hydrogen, which is just a proton, susceptible to leaving, going into solution, or bonding with another molecule. So carboxyl is acidic. The next group, the next functional group is an amino. So an amino, we've got R bonded to a nitrogen, which is bonded to 2 hydrogen atoms. Okay. So it's called amino, and that refers to the nitrogen. You could also write it as just RNH2. And the characteristic of this functional group is that it's basic. So basic means that it's going to easily gain a hydrogen ion. So it's often going to have an extra hydrogen ion. So you start off with your nitrogen with just 2 hydrogen ions, but it's a little bit electronegative. And so if you have another hydrogen ion just hanging out in solution out here or in another molecule, it could easily bond to nitrogen. Nitrogen can actually form 4 bonds. Oops, that was a hydrogen. Okay, so nitrogen can form 4 bonds. And so then this whole molecule is going to be positively charged. It's gained a hydrogen. And so again, it's basic. Okay. So we're over halfway done with our functional groups. We're going to move on to the next one, which is called sulfhydryl. So sulfhydryl, got an R group, and it's a sulfur and a hydrogen. Called SUL, let's have to look. SHY DRYL. Sulfhydryl. Okay. So sulfhydryl. And this characteristic is, it's got several, but what I really want you to know is that this is really important in protein bonding. And it's going to be bonding at what's called the tertiary level, which is the 3rd level. So if you're interested in that, you can look at the video on protein bonding. It's actually going to form a covalent bond. So you've got an R group and an SH. And then say this molecule actually wraps around over here, the big old protein, and over here you also have another functional SH. What can happen is that these hydrogens will actually leave, and then you will actually have a covalent bond between these 2 sulfurs, and that's going to be a very, very strong linkage that's going to hold this molecule in place. So that's what you need to know about the functional group sulfhydryl. All right, got 2 more. We have a phosphate. So this is a really important functional group. The phosphate, we've got our R, and it's PO4, and it actually has a -2 charge. So the phosphate, if I was to draw it out, showing the covalent bonds, you've got oxygen, and then phosphate, which is bound to 3 more oxygens, 2 of which have a negative charge. So this functional group has the characteristic that it's extremely high energy. It's going to be involved in a molecule called HEP, which is the energy currency of the cell. It's got this really negative electric charge, so -2, and it's got these double bonds, which are highly reactive. So they're like springs with a lot of stored energy. So you need to know that it's high energy and also that it has a negative charge. So like this is found on DNA, and every subunit of DNA has a phosphate group. So overall, the molecule DNA has a large negative charge, which is going to be really important for biotechnology and using it to move it across gels and things. So that's also an important characteristic. All right, the very last one is a methyl group. This one is uncharged. So it's found a lot in like fatty acids. So R is bonded to a carbon and 3 hydrogens, CH3 of methyl. And this methyl group, if I was to draw it out, we've got carbon. Again, carbon makes 4 bonds. So I have 4 single lines attached to carbon. And these electrons are very evenly distributed. So the electrons are going to spend the same amount of time around carbon as hydrogen. So there's really no uneven distribution of charge. And so this is non-polar. So it is not going to interact with molecules like water. Something that has a lot of methyl groups is not going to dissolve in water. So this is really important, and it's a characteristic associated with lipids or fats. All right, that is it for the functional groups.